As RT already pointed out, WinDRBD is DRBD for the Windows family of operating systems. It comes with almost the same feature set, with a few notable exceptions. For example, there is no auto promote on the Windows port. The reason for that is that there is no clean way to open a block device on Windows. It's something operating system specific. So, but for the rest of the features, you can, most of the other features are implemented. It is, of course, wire compatible to the Linux version. So you can have a mixed Linux Windows cluster. We also have production clusters in the field where, for example, two Linux diskful nodes are serving a diskless Windows client. Most, as far as I'm concerned, most nice feature about WinDRBD is that it's completely based on the original DRBD source code with a few patches, but those patches are less than 1%. So I guess currently the patches are 200 lines added, 100 lines removed. Given that DRBD itself has 30,000 lines of code, it's less than 1%. And I'm working on reducing it even more, but this is another topic. Yeah, WinDRBD itself is kind of a compatibility layer, or let's say a kernel framework, which maps Linux kernel APIs needed by DRBD to Windows API functions. I'll give you a very simple example. For example, if you have spin locks used for synchronization in kernel mode software, the Linux version is called spin lock, and in that case, it just calls the corresponding Windows NT spin lock plus some extra work. So it basically allows us to reuse most of the DRBD source code in a Windows NT kernel. So this is what I've been doing the last 7 years. And you don't have to boot Linux on your Windows machine because the output of the whole thing is a WinDRBD sys file, which also comes with a nice installer, which I'll show you later. So yeah, this WinDRBD sys file contains the DRBD compiled objects and also the WinDRBD, this kernel framework code. So yeah, WinDRBD 1.2 is a development branch which is quite stable already. It came mainly due to the fact that the patching system for DRBD became unmaintainable in the 1.1 branch. So we couldn't switch the DRBD engine to 9.1 or 9.2. So 1.1 is based on DRBD 9.0, which is not supported anymore by upstream DRBD. So with WinDRBD 1.2, we can have 9.1 and 9.2, and hopefully soon 9.3, with including the nice feature Joel just showed us. And we also reworked the build system. So in 1.1, it was necessary to have two different virtual machines. You have to compile DRBD utils separately, and also the patching mechanism was very not so well maintainable. It's all much better now because, and last but not least, we are compiling with the new CC compiler. So compiling with Microsoft Visual C doesn't work anymore. This makes sense because DRBD is a Linux kernel driver and it makes use of many GCC extensions of the GCC compiler. So we save on many patches we don't need anymore in the DRBD, in the WinDRBD 1.2 branch. And the patches that we need are now in the Git repository on a separate branch, of course, of the DRBD repository. And last but not least, we support also other architectures. Right now, this is, of course, 64-bit, but also 32-bit, and we also support reactors. I will explain later why we do that in particular. Yeah, the current status, it's quite stable already, so we are expecting a stable release in the next, let's say weeks, or maybe 2 months or so. We did many endurance tests, like running I/O for 1 week, primary, secondary for 2 nights. So the basic stability is there. I'm currently working on automated testing using the DRBD9 test suite, and actually yesterday my patches to the test suite. So this is not DRBD, but it's the test suite that tests DRBD. Yesterday, it got my Windows patches got merged into that test suite. So thank you, Joel. Yeah, it was a great experience working with you on that one. And of course, that's one of the reasons I'm doing this talk. We are looking for volunteers for testing WinDRBD. Of course, we test it ourselves, but if you have more eyes looking on it, then yeah, it's always proved to be very useful if we have testers in the community. So let's see. Yeah, there are some to-dos. The first of two are necessary for the stable release. I will only talk about it briefly. The create device secure means that currently in WinDRBD 1.2 you can manipulate DRBD resources also as a normal user. So without being administrator or something. This is, of course, something we need to fix. For some reasons, it's not so easy to do this, but will be done, of course. And the other one is the structured exception handling. I talked to Philippe today, and he was like, oh, God. It means that it's still C code, but you have a try catch except block in the C code. It's something that's very specific to Microsoft, and we got it working on the 32-bit version, but not yet on the 64-bit version. And we are fortunately, we get help from the reactors community in implementing this, because I could never figure out how to implement this correctly, because it's it's a very new thing in reactors. Yeah, the other things, of course, making new tests work is always a good idea. Yeah, let me briefly explain the reason why we support reactors. It's very useful for debugging, because as we use GCC for compiling, we can't use the Microsoft kernel debugger. But we can build reactors and WinDRBD with GCC, and there we can use the new debugger, the GDB, to debug the driver, which has proven very useful in debugging WinDRBD issues. And another thing is we also use the reactors headers in our repository because the upstream MinGV GCC only supports user mode Windows, but not the kernel mode Windows development environment. And yeah, we are also using very old Windows NT kernel APIs, as Windows is, as a Microsoft Windows is not a closed source operating system. They can't change the kernel APIs, so they have to keep them for 20 years or so. And as of a result, we can use very, very old Windows NT kernel APIs. The only thing we had to implement for reactors is the NetIOSys driver, which hopefully gets merged into reactors soon. And last but not least, reactors is also GPL. And yeah, it's, to me personally, it's this open source spirit that the community makes. I don't know if somebody from reactors is listening. If yes, then I say hello. And thank you for the support and the headers and everything. So let me go. Do you still hear me? I don't have an idea.
Yep.
If I'm
Yes,
Yep.
we can hear you.
okay. Then yeah, let's go to the website. You see the web browser probably.
Yep.
Yeah. You just go to GitHub, LINBIT, WinDRBD. And then there's the stable branch. Stable is currently WinDRBD 1.1 for some time. So we'll 1.2. And so, okay. And as you can see here, I don't know if you see the mouse pointer, but we have several submodules, DRBD 9.0, 9.1, 9.2, and soon DRBD 9.3. So this project uses a lot of Git submodule features. It also includes the DRBD utils, and it also builds a small tool needed to generate a catalog file for Microsoft. This is something Microsoft specific. Yeah, I wrote it from scratch, and it's never mind. Yeah, and what I wanted to show is just to take this and get going. And what it does, it clones all the submodules. That's why you need the recursive. Yeah. And the build process itself is done in a Docker image. This has two reasons. One reason is that it's much handier to have a Docker image which you just can pull like this, like pull Docker. You can also create it like this, make Docker. And the other reason is that for some reasons, we need the SIGWin compiler to compile the DRBD utils. And for some reasons, it's not trivial to compile this compiler for the Linux platform. Yeah, I spent 3 days on it and didn't succeed. Okay, but if I have time, then I will do that. Yeah, so let's. Oh yeah, wrong directory, of course. What I do is I give a version string like community meeting demo, and as you can see, it starts Docker. And what the Gotchi process does, it contains generic patches. So one important patch is, unfortunately, on Windows there is no C data type that is a machine word. So you have unsigned long in Linux is 32 bits on Linux on 32-bit machines, and 64-bit on 64-bit machines. But on the Windows platform, for whatever reason, the unsigned long type is always 32 bits. So we have to replace all occurrences of unsigned long with a special Windows data type, which is called ulong putter, PTR, and this is what the Gotchi script, for example, does. There are also other things related to spinlocks, and as you can see, it also picks the DRBD utils, and we already have a driver, the sys file. We also have a CAT file, the security catalog file, which is also being signed. And last but not least, it creates a installer, which I will copy to a Windows machine, administrator, like this. And as you can see, it contains the version name we had, and it contains the DRBD branch, and it contains the architecture. So let's do it. So it was very fast, so it should be here. Let's see, community, okay. Let me just get this out of the way. Okay, yeah, and just to make sure, we are here on a Windows machine like Cygwin. Cygwin is POSIX emulation library for Windows. It allows to compile most Linux programs for Windows, and it also comes with a secure shell server, which is very handy. So I don't have to use the Windows desktop. Yeah. If I just start this with very silent, and with no restart, just to make sure that it doesn't take some while. Meanwhile, let me show you some other. Make help is very useful. I can, for example, build for DRBD 9.1. So same thing as before. I hope this terminates one time. Let's see what it's doing. It's still disconnecting. Okay. It has to yeah, it has to shut down the DRBD resources. For some reason, it doesn't do that right now. It's a demo effect right now. Okay, now this is the demo effect. Usually this works, and you would have the new version then on this machine. It's really strange. It fails on a disconnect, or it just takes forever. Okay, fortunately I have another machine. Now it continues. Okay. Okay, installs some files. Yeah, and what I wanted to tell you is that there is LINSTOR for Windows. And this is a nice thing. because it handles all the, you know, the firewall and the backing device. So it's very useful to have LINSTOR on, let's say, LINSTOR node list. Yeah. And as you can see, this W2 is our DVD machine, where we now have the community meeting demo. So the installer just takes some time, but usually it finishes its work. Yeah, I can do all the LINSTOR features. Yeah, it's right now it's still connecting. Let's see what it says here. Okay. Yeah, it takes some while, but yeah, that's basically it from my side. Yeah, is the wanted to point out is some lessons learned. So we're using just open source tools to build, like GCC, the GenCat file, the OSSL signed code utility, Linux, of course. And we use Sigwin for the development machines, which is very handy. So you don't need the Windows desktop. You can do everything with a secure shell. And also in the driver code, I tend to use more the Linux versions of the API, like wait event, for example, because it's much powerful than the Windows versions. Yeah. I recently, last week, had a talk about why WinDRBD does not bite. And the thing was, all of the listeners were Linux developers. And I'm the only one who does the Windows at LINBIT. And as you can see, there is no Windows desktop needed. So conclusion is Windows is just a another Linux distribution if you have the right tools to work with them. Thanks for listening. Any questions anytime now or later? Thank you very much.
Awesome. Thank you, Johannes. Yes, we did have a few come in while you were presenting here. It looks like Brian in the chat had to drop for another meeting, but we'll get his question answered anyway, so we can send it over to him. He asked for some of the common use cases of WinDRBD, and he went on to say, can he use it to add a Windows machine to a LINSTOR cluster, or at least use it to mount block resource from LINSTOR natively using DRBD without using something like iSCSI?
Yes. Yes. You can use it in a LINSTOR cluster as any node, disk full, diskless. What it uses as because there is no device mapper yet for Windows. Right now it uses storage spaces. So you have to set up the storage spaces or storage pool, which is a simple PowerShell command. But other than that, you can use it transparently in a LINSTOR cluster as well.
Awesome. Great to know. We also got one from Andre. He said, can WinDRBD be used for Kubernetes in Windows?
Okay. There is Kubernetes. Moritz, there's Kubernetes for Windows?
Yes, there is Kubernetes for Windows.
Well, it does not. I'm sorry, I'm deep in the kernel.
In theory, I think nothing. There shouldn't be a technical problem other than we haven't implemented it, and yeah. So the CSI part is a bit different, I think, for the Windows stuff, but.
Okay, but it's something something on the to-do list, on my to-do list. No worries, not on your to-do list.
Awesome. And then one more from Andre. He asked about WinDRBD replicating with Linux.
Yes, it's seamless. So yeah, whatever data you put on the Windows side will appear on the Linux side. So it's just, yeah. This is something actually it was one of the first things I took care of when I got this project back in 2017, is that it's compatible with the Linux version, so I can test it better. But now it's, yeah, it's never caused any problems replicating between Windows and Linux. Of course, you have to choose a file system which is supported by both platforms. But this is another piece of cake. This is one layer above WinDRBD. So, yeah.
Awesome. Thanks, Johannes. Give it another sec here. I think that covers all of the questions. As always, please put more questions in the YouTube comments if they come up later.